afternoon, students. I am Dr. Srirupa Banerjee of Department of Chemistry, Betun College. Today I will teach you organic chemistry. The subtopic is stereochemistry, and between stereochemistry, today we will read about conformation. Conformation. In conformation, there are some important terminologies such as conformations, conformational analysis, conformers, etc. We are starting with conformation. Conformation is innumerable arrangements of the atoms in space that results from rotation about single bonds. Now I am trying to explain you what is conformation. If you think this Newman projection formula of ethane, this is the front carbon, and that side there is another carbon. In each carbon there is 3 hydrogen. Please let me start with laser pointer. In this 2 carbon there are 3 hydrogens. 1, 2, 3 in the front carbon and 1, 2 and 3 in the back carbon. Now, if we keep this front carbon fixed and rotate the CC bond we can see this spatial arrangement. That is, this hydrogen goes over here like this. This hydrogen goes over here like this, and this hydrogen goes over there like this. So, this hydrogen over here, this hydrogen over here, and this hydrogen over here. Now, if we slightly rotate these 3 hydrogen again, we can end up with this conformation. Now, this CC bond can be rotated in 360 degree. So, there are small rotation will generate new conformations. So, there are innumerable number of conformations possible. So, conformations are innumerable, whereas configuration is fixed one. You know that from your same one stereochemistry, that conformation is fixed, but conformation is innumerable number possible arrangements of atoms in space. So you are well known about the conformations, that it can be innumerable. The small rotation will generate new conformations, and this is a very simple example of ethane by which we can show that the innumerable conformations are possible. So, conformations are innumerable arrangements of atoms in space that result from rotation about single bond. Now, next topic, conformational analysis. This is a study of physical and chemical properties of compound in terms of various conformations. Now, I clarify this terminology, conformational analysis. This is a compound. This is known as ethane. Now, if we rotate the back carbon slowly, it will generate innumerable conformations. After that, we will get different type of conformations, such as like this one, where 2 hydrogens are very close from first carbon, this hydrogen, and from the back carbon this hydrogen, they are both are very close to each other. And if we consider this one, this has a considerable distance between these two hydrogens. There are considerable distance between these two hydrogens. So now the possible conformations can vary in their properties. So there are some physical and chemical properties. Here are some physical and chemical properties by which we can differentiate different conformations, and the study by which these physical and chemical properties of a compound we can discuss. This is known as conformational analysis. The conformational analysis is a study of physical and chemical properties of compound in terms of various conformation. As I discussed, this is a conformation and this is another conformation, but they varies in their physical and chemical properties. So this study is known as conformational analysis. Now the term conformers. Conformations of minimum potential energy are known as conformational isomers or conformers. Now these conformation have some energy. This conformation has some energy, but they are different. We will look out in the matter where the energy, which one has higher energy, which one is lower in the next slides. But now this is important to know that their potential energy is different. Different conformations have different potential energy. Now, in all possible conformations of ethane, if we see carefully, this type of conformation will lead the minimum potential energy. We will look out in the matter in our next slides also, but for the time's sake, we can consider that the minimum potential energy conformations are the conformer. Now, in a potential energy versus dihedral angle curve, we will know it later on. We will get some energy minima position where this type of, if we consider ethane, this type of conformations will be there and they are known as conformers. Now, we know about these terminologies: conformational analysis and conformers. Now, the next terminology is eclipsed and staggered conformations. As we've seen in our previous slide, this is ethane. This is ethane. This is the front carbon and there is a back carbon, and this front carbon has 3 hydrogen over here and back carbon also have 3 hydrogen over here. Now, আমরা সবাই জানি what is গ্রহণ, eclipse. So, this hydrogen eclipsing this hydrogen. মানে যেমন চাঁদের ছায়া পড়ছে সূর্যের ওপর, চাঁদের ছায়া পড়ছে পৃথিবীর ওপর, সেরকম দিস হাইড্রোজেনের যে ছায়া সেটা পড়ছে এই হাইড্রোজেনের ওপর. So this is eclipsed in position. Now this is again eclipsed and this is again eclipsed. This conformation is known as eclipsed conformation. Here CH bond on front carbon eclipse CH bonds on back carbon. This circle is made to depict the front carbon atom, which blocks the view of the back carbon. So, this is the staggered conformation. Now, sorry, this is the eclipsed conformation. Eclipsed conformation. Please rectify. This is the eclipsed conformation. Now, this is staggered conformation. These hydrogen CH bonds on front carbon are maximally separated from CH bond on back carbon. This is front carbon, and behind that circle there is another carbon which is back carbon, and this CH bond on front carbon is maximally separated from CH bond on the back carbon, and this conformation is known as staggered conformation. Different types of conformations mainly arise due to van der Waals repulsion forces, though it is too small to account for, and interaction of the electron cloud in the CH or CC bonds. So we can imagine that in the eclipsed conformation, this CH bond is eclipsing the CH bond of the back carbon, and this CH bond has a van der Waals repulsion with that CH bond which is on the back carbon. But in this case, there is no such van der Waals repulsion. So this is energetically higher and this is energetically lower. The maximal separation is here. So this is least energy content, and this is a staggered conformation. And according to previous slide, since this is the least energy content conformations, so this is a conformer in case of ethane. Now, energy profile, graphing the rotational barrier in ethane as a function of dihedral angle. The barrier to rotation in ethane is about 3.0 kilocalorie per mole. What does it mean? If we plot this curve, this ethane molecule, you know that this is the eclipse conformation of ethane molecule. If we keeping the front carbon fixed, if we rotate the back carbon in 60 degree in each by 60 degree in each rotation, we will get, after 60 degree we will get this one. Again after 60 degree, this hydrogen will go over here. It will generate the same like this one. After that, again 60 degree rotation will generate this staggered one, which is similar with this 2, that is 2 and 4 with same energy content. Since both are hydrogen, we are rotating hydrogen and all of the substituents are hydrogen. And again, when this hydrogen, we are labeling this hydrogen as a red color so that you can view it clearly. So this hydrogen again goes over here after 60 degree rotation, and we will get this one, and this hydrogen again goes over 60 degree rotation to get the staggered conformation. And after 360 degree rotation, we will get the similar 7 eclipse is a eclipse conformation like 1. So 1 and 7 are same molecule. In case of ethane, all the 1, 3, 4, 5, 7 are same. And in case of ethane, again 2, 4, 6 are same. Now 2, 4, 6 are staggered conformation, and 1, 3, 5, 7 are eclipsed conformations. Now, since all the 1, 3, 5, 6, 7 are same in energy, so in the potential energy curve, they are like this. And since the staggered conformation contain similar energy at the minimum energy, and so they are like this. Now, in the potential energy curve. Now the difference of energy between this eclipsed conformation and staggered conformation is 3 kilocalorie per mole. In ethane, energy maxima 135 corresponds to eclipsed conformation, as I told you before. And in ethane, 3 energy minima 2, 4, 6 corresponds to staggered conformation. Now, this is the conformational analysis of ethane. Now, gauge, scene and anti-conformation. This is also again some terminology. Now, for this conformation, for this terminology, we like to draw the potential energy curve of butane. I will teach you the potential energy curve of butane later on in some other class. But today we are taking the example of butane, and we are starting from the eclipsed conformation of butane. Now, this is the butane conformation. This is the eclipsed conformation of butane. If we rotate this molecule, this CH3 by 60-degree rotation, we will get the conformation like this. And after again 60-degree rotation, we will get another eclipse conformation, but these two eclipse conformation is now different. In ethane, all substituents are hydrogen, but in this case, in front carbon there is a CH3 and 2 hydrogen atom, and in the back carbon there is again a methyl and 2 hydrogen molecule. Now, after 60-degree rotation, we will get another eclipse conformation. Here the eclipse conformation, there are 1 methyl-methyl interaction, 2 hydrogen-hydrogen interactions. But in this case, in this eclipse conformation, here 2 CH3H interaction and 1 HH interaction. Now, if we rotate this one, in this case, there is 2 methyl in the 60-degree rotation, but in this case 2 methyl are in the 180-degree separation between them. So again we are going to show the eclipse conformation over here, and this is same with this, because these two has the same energy content, 2 CH3H interaction and 1 HH interaction. And after that, when we rotate this methyl again by 60-degree, then we will get the conformation like this, which will give the same energy content like this one. And after rotation of 60-degree, we will get the previous one, which is as similar as the first one. Now, if we consider the energy content between these 3 conformers, now these 3 are conformers in the energy profile diagram, since they are belonging the energy minima position. Now, this is the energy minima position, this is the energy minima position, and this is again the energy minima position. And these 3 are in the energy minima position. So, these 3 are conformers, and there are difference in energy content in between these 3 conformers, and this but they are staggered. They are staggered conformations. They are conformers, but they are differed in energy, and the energy difference between these two, that is the gauge, this staggered conformation and this staggered conformation. This is the gauge conformation, and energy difference between these two is known as the energy difference between these two is known as gauge-butane interaction. This we will learn it later on, and this is known as anti-periplanar staggered conformation, and both of them are gauge and they are staggered.